Good afternoon, everyone. We are Team MIXDEV. My name is Alal Bashir, and here's my team members. So, in the introduction, let's begin with the contest. As many of you know, quality management systems are the backbone of any organization certified under ISO 9001-2015. These systems are essential for ensuring consistency and compliance. However, the current reality for company XYZ is far from efficient. They are still relying on manual process, uh, like spreadsheets, physical paper, documentation, and email chains to track their attitudes and corrective actions. This approach creates significant risks, and it is time consuming and error prone. More importantly, it makes it nearly impossible to maintain real time transparency. If an editor asks to see the history of a document right now, it would take hours to find.
Okay, so for the scope, so QMS Flow is a web-based system designed to support ISO 9001-2015 compliance, and it replaces the manual paper-based spreadsheet-driven quality management processes. And overall, it provides a centralized platform to manage all quality-related activities in one place. So what the QMS Flow does is that it automates the key quality process, such as document control, audits, and it also tracks the employee training, equipment records, and calibration schedules. As for what the QMS Flow does not do, it does not perform technical inspections or physical measurements, and it also does not replace external calibration laboratories or production systems. The final ISO compliance decisions are still made by quality assurance personnel. So the key benefits of this QMS flow would be that the system improves overall compliance and audit readiness by maintaining a structured records, and it reduces the manual work, delays, and human errors through automation. At the same time, it enhances the traceability and accountability across the organization. As for the goals and objectives, the main goal is to standardize the processes, and it aims to improve visibility and response time for audits and non-conformities. And finally, the system is designed to support scalability as the organization grows. Start with system requirements. So here we start with the user story US 001. For the persona one, which is manager, actor one, we have an actor called Mr. Daniel Lim, and his role is quality manager of company XYZ. So the background of Mr. Daniel Lim is he has over 8 years of experience in managing ISO 9001-2015 audits, CPA processes, and document control. He is familiar with quality regulations but relies heavily on manual spreadsheets, emails, and shared folders to track compliance activities. He is moderately tech savvy but prefers systems that are simple, clear, and fast to use. Okay. User needs a quality centralized digital system to manage audits, approve documents, and track CPA activities to ensure continuous compliance with ISO. Okay, so next for Persona 2, which is the admin, Aisha Rahman, which is the system administrator. So Aisha is responsible for managing user accounts, roles, and system configuration within the QMS flow. She's highly tech savvy, comfortable working with dashboards, and ensures that the system operates smoothly and securely. While she doesn't participate directly in audits, her role is critical in supporting the overall system infrastructure. Ultimately, Aisha needs a system that allows her to manage users and modules efficiently, ensuring QMS flow is reliable, secure, and easy to maintain. By providing her with these tools, we can reduce her workload and improve the overall efficiency of the system.
Next, we have our third persona, Sit Amina, who represents our general employee on the production floor. Who is she? Sitti has been with the company for 3 years. She is very responsible with her daily tasks, but she finds complex computer software intimidating. She is comfortable with the smartphone, but she is not a desk worker. And for the user needs, an employee needs a simple mobile-friendly interface to view documents and submit logs without navigating complex and administrative menus.
We have system pages. So system features describes the overall system features of QMS Flow. QMS Flow is a web-based and cloud-enabled quality management designed to replace manual and spreadsheet-based workflows. So this system is designed using a modular architecture where each quality function is implemented as a separate module. So for this use case diagram, it visually represents how different users interact with QMS Flow. Quality managers have access to advanced functions such as audit scheduling, document approvals, and CPU tracking. Admins manage users, accounts, and system configurations. Employees have limited access mainly to view documents, submit forms, and complete training tasks. This diagram clearly shows role-based access control, which is essential for security and compliance. Next, domain model. Domain model diagram shows the relationship between key system entities such as users, documents, audits, CPAs, and training records. It helps us understand how data flows across the system and how different modules are linked. This ensures strong traceability, which is critical for ISO audits. This state machine diagram illustrates how key objects change states over time. For example, a document moves from draft to under review, then to approved or rejected. This prevents unauthorized modification and ensures that only approved information is used in operations. State control strengthens compliance and audit integrity. So, overall, this system features of QMS Flow provides a structured, secure, and scalable solution for quality management. Next, user story. Let's start with US001 document control management. User story 001 focuses on document control management, which is a core requirement of ISO 9001:2015. Document control ensures that only approved and up-to-date documents are used within the organization. This sequence diagram shows how Quality Manager interacts with the QMS Flow system and database. First, Quality Manager sends a request to upload or update a document. The system validates the inputs, checks versions of uniqueness, and saves the document in database. Once the process is complete, the system sends notification to users. This diagram highlights how the system responds in a structured and automated way. Next, activity diagram visually represents the step-by-step workflow of document control. It shows the sequence from login, document, upload, validation, approval, and notification. Decision points in the diagram handles cases such as missing information or duplicate versions. This diagram helps ensure that no document bypasses the approval processes. Okay, so for user 2, user account management, I'll talk about the sequence diagram. So the sequence diagram shows who interacts with whom. So this one illustrates the interaction between the admin and the system components over time during the user account creation process. So the admin will send a login and user details to the system. The system talks to user management service and database to validate and store the data. Then the email service will send a login credentials. And finally, the system confirms to the admin that the account is created. As for the activity diagram, this activity diagram shows the overall workflow for the user account management process in QMS Flow from the start to end. The admin logs in, goes to user management and selects create new user. The admin then enters user details and the system checks for errors or duplicates. And if it's all correct, the system creates the account and sends a login email. And the process ends when the account is ready to use.
So for the user story 3 activity diagram, the workflow for the scheduling a new audit, this process is initiated by the quality manager. The flow, the user starts by logging in, then navigating to audit management. They select schedule a new audit and enter the key details, the date, the scope, and the assigned editor. The most critical part of the diagram is the decision demand. Here labeled is editor available. If the editor is free, the system saves the schedule and automatically notifies the editor. The process then ends successfully. If the editor is not available, the system triggers an alternative flow. It displays a warning editor unavailable and loads the user back to update the date or choose a different person. Next, we have sequence diagram, which details the technical communication between the system components during the same scheduling process. We follow the model view controller. We have 4 lifelines, the quality manager, the user, the edit page, the view, the controller, and the database. The process begins when the manager submits the edit details. The edit page sends a message to the controller to validate availability. Validation. The controller queries the database to check schedule. You will notice that the large box labeled alt. This represents the conditional logic we saw in the previous diagram. In the top section, if the database returns the salt is open, the controller sends a save adjust message to the database and triggers send notification to editor, and finally display success message to the user. And that's all.
Performance requirement. This describes the performance requirements of QMS flow. These requirements define how fast, reliable, and scalable the system must be to support daily quality operation. Since QMS flow is used in a manufacturing environment, good performance is essential to avoid delays and disruption. For the response time, QMS flow must load dashboards and retrieve documents within 2 seconds under normal network conditions. This is important because employees and managers often need quick access to SOPs and record during audits or production activities. For throughout, the system must support at least 100 concurrent users accessing the database at the same time. This requirement ensures that the system does not slow down or crash during peak usage. QMS flow is required to maintain 99.9% system availability during business hours. High availability is critical because employees rely on the system to access SOPs and quality records needed for daily operations. System downtime could lead to production delays. The system must be scalable and able to store at least 5 years of audit logs and compliance data without performance degradation. Scalability ensures long-term usability and compliance. Okay, for software system attributes, there's 9. So security ensures the sensitive data is protected and only authorized users can make changes. Usability makes the system easy to navigate. Employees can access SOPs quickly even on mobile. Reliability keeps the data safe with daily backups, preventing loss during failures. Maintainability allows updates with minimal downtime. Portability means it works on major browsers and mobile devices. Compatibility ensures it can connect with other systems like HR or maintenance. Safety protects approved documents and audit records from deletion. Legal and regulatory compliance follows Malaysia's PDPA and ISO 9001-2015 standards. Environmental features reduce paper use and support energy-efficient servers. And overall, these attributes make QMS flow secure, reliable, compliant, and long-lasting. Okay, next.
Finally, we outlined the design constants, the non-negotiable rules that shaped how we built QMS flow to ensure it actually works in real factory environment. First, technical accessibility. We recognize that not every worker has a high-end computer, therefore we constructed the system to be fully functional on low-end office PCs and standard smartphones. This ensures the production staff, like our personnel city, can access the system from the factory floor without needing expensive hardware. Second, regulatory compliance. Since this is a quality management system, following the rules is critical. We strictly adhere to ISO 9001 2015 standards, specifically enforcing that no document can be permanently deleted without an administrative archive log, ensuring full audit traceability. We also comply with the BDBA, Personal Data Protection Act, to employee training records. Third, operational and environmental reality. We designed the interface for the physical reality of the manufacturing plant. Visual alerts, because factory floors are noisy. We prioritized visual notifications over audio ones so workers don't miss critical alerts. Security, we implemented strict rule-based access control. This ensures that the general employee can view SPOS, SOB, but only authorized quality managers can access sensitive adult data. In summary, these constraints ensure the system is not just complement with the law, but also practical for the daily conditions of the factory. And that's all. Thank you.